we should be fine to get through it in a reasonable amount of time. All right, so these ones say to use analytic methods to find local extrema, the intervals on which the function is increasing and decreasing. G of x equals x squared minus x minus 12. So the first thing I want to do is find the first and second derivatives. So, first derivative would be what?
2x minus 1.
Yep. And second derivative?
2.
Beautiful. All right, so this equal to 0 and solve. So x equals 1/2. So now we need to determine if this is going to be a max or a min. So our second derivative is just 2. So what do we think? Well, what is this?
Wait.
What is this a graph of?
The.
Parabola.
Okay, and it goes this way, which means
Oh, so
what?
that's min. Yeah.
It has to be a min.
Right. I think I should get my own cookie points. Like my own set of cookie points when I get something right and Josh doesn't. And then you have to buy me a prize, Josh.
So there's a min at x equals 1/2,
I get stuff right and you don't.
but the actual point is g of 1/2, which is 1/2 squared minus 1/2 minus 12. Which, just to save us some time getting common denominators, would be negative 49 over 4. So, that means then that we have a min at 1/2 and negative 49 over 4. Then I want to know where it is increasing and decreasing. So based on what we know, where would it have to be increasing?
Points like 2 and above.
2.
1/2.
Oh, 1/2. I mean.
Yes.
Well, I pictured it right in my head.
Yeah,
1/2
so
to
you wanna
infinity.
get a personal cookie point now.
No, I corrected myself.
After I said the right answer. like, girl, what? No, that's.
So then where is it decreasing?
Anything below 1/2.
Negative infinity to 1/2. And it's including on the 1/2 on both, technically. That's where it like turns around.
You know, I just realized. Oh, that's bad.
What?
I haven't had a single sip of my water today.
I thought you were supposed to thought you were starting your day with a whole bottle of water.
That did not happen this morning. I woke up and I could not wake up. I was like, I can't even do the whole water thing. It was freezing in my house. I was like, I just need some energy. And then I never went to the water. And now my shirt is wet. This is why I don't drink
I've done
water.
that before.
This is why I don't drink water.
This is why you need your Stanley.
I know.
I mean, I've spilled water on myself plenty of times at school.
My mom even
And I still
washed
drink
it
it.
for me, and I just didn't fill it up.
just can't read. That's the problem.
Maybe my taste buds go crazy.
All right. First derivative.
4x cubed minus 20x.
Yay.
Second derivative.
12x.
What does that
12x
mean?
squared minus 20.
Yes. Yes, I'm mocking.
Yes.
Yeah.
All right. Now I need to look for critical points. So I set this equal to 0 and solve. So I would say factor out of 4x first. So that'll leave me with x squared minus 5. So 4x equals 0. Thus x equals 0. Then x squared equals 5. I'm just moving all this stuff over to save steps. And then x equals plus or minus the square root of 5. That's good. Had to explain this morning in college algebra how when we are solving log equations, you may get an answer where like x is equal to like plus or minus the square root of something, but you can't have the negative square root or like a negative log, so you can't use the negative value. They were like, what? And so then I had to like show it on the calculator and be like, this is undefined. We can't have negatives.
I only know that because you said it. I don't know why. Or it doesn't work, but I just know it doesn't.
All right, so now we need to use our second derivative to test these points and see what's happening to determine if these things are mins or maxes. So the second derivative evaluated at 0 would be 12 times 0 minus 20, which is negative 20. So what does that mean? Max. Second derivative at negative root 5 is 12 times negative root 5 squared minus 20 equal to 40. So what does that mean? Min. And obviously, well, I think it's obvious that at the square root of 5, it's going to be the same thing since it was squared. So that one's also 40 and thus also a min. So part A here, I have a max at, oh, I guess I need to actually plug in the number and see where it's at. Well, when I plug in 0, what is the initial? 9. And then I have mins at negative root 5, and I have to figure out what the other number is, and positive root 5, and figure out what that is. Which, do we agree that they're going to be the same number either way when I plug them into the original? Because they're both to even powers, so it's not going to change whether the sign is positive or negative. So I only need to do it once. So the square root of 5 raised to the 4th minus 10 times the square root of 5 squared plus 9. So this is just in the original here. Whoa, that was weird. There. So that's what? 25 minus...
Were you waiting for us to answer that one?
Yes.
Oh, okay, I thought you
You
were
were
just
saying
blanking.
you got this.
I thought you were just gonna like keep going. And I was waiting for her to say 50, and it's like, why isn't she saying it? Like I know she got, I know she knows
I was so confused.
this.
I was looking down, and I thought you were saying it to me. You were looking over there. I was like, what?
No, I knew you didn't got this.
Yeah.
So
No, I just started it, and then I was like, are you going to say it?
I thought you were gonna say it. I was waiting.
Like, come on, you got this.
I thought she had to like think about it or something.
Your
It's
moral
like, why
support
is it
gave
taking
her
so
the
long?
answer.
Alright, so wait, it's negative 16, not positive 16. So then now I need to figure out where it's increasing. So where is it increasing from?
Negative root 5 to 0 and root 5 to infinity.
Yep. Do we understand how we're getting those?
No.
I do.
So at a min, that means it had started high and it went low, so that would have to be decreasing. And then at a max, it had to start low and go high. So it would be increasing. She looks super confused.
I kind of understand. Is that so? That's why it stops. In
So technically, it would be this point, then this point, then this point in order. So this is a min, so that means that it's going down, down, down. It gets to this point, it goes up, 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 gets to this point, goes down, 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 gets to this point, and then goes up, up, up again.
Okay. That makes sense. I think a little more.
So we're just basically determining at a min, then on the right side of the min values is where it's increasing. On the left side would be where it's decreasing for mins. So decreasing would be what?
Like, would 9 be one of them, or no?
So that's a y value. So we're just looking for
Oh,
the
just
x
the
values.
x's.
So your first min is here.
So we go
So I have to be
negative
going down
infinity.
prior to that.
So negative infinity to negative root 5. And you got the other one. You need practice with this too.
Hold on, let me think.
And he's not asking me this time.
Yeah.
Right. You got this.
So on the left side of your mins, it's decreasing. Or the right side of your max.
So like 0 to infinity? No.
It can't be that because that's intersecting these other intervals.
Yeah, I don't think.
0 to infinity is including another min value, so it can't be that.
Something to infinity?
Can't be infinity because it's including this value if you do that.
Shall I just say the answer?
What's the interval that we currently are missing?
The first one? Or like-
What?
Wait. Oh, we're missing.
So this one goes here before this
Oh,
one.
we're missing the last one.
Then
Wait, I don't think I understand.
then we've got this one in between this point and this point.
How many cookie points am I gonna get from this one?
After this point, I don't have an interval. I need the interval that's between this point and this point.
What? Wait.
Y'all might not have time to study for
Is
government.
it any of those numbers? Or any
Interval
of
is 0
X
root
values.
0 root 5?
5. 0 to
What?
5. That's the interval we're in here. I want to study for government. Done with you.
I don't
0 to
think I
root 5.
understand what's going on.
Well, I do, so.
So your graph looks something like this. Okay, so it's decreasing from negative infinity to negative root 5. So it starts out going down. At negative root 5, okay, so we're here. I don't know what exactly this graph looks like. I'm just approximating. Then it turns around and it starts going up. So it goes something like this. Oh, nope, curve, come on. Okay, so it goes up like this, until I get to 0, to this point that's the max. Then it turns and it comes back down, which is this 0 to 5 interval we just did. And then when we get to root 5, it turns and it goes back because this was a min. So this is your first min of this point. Your max is this point, and this is a bad graph, but anyways, you get the point. And then this is the other min.
Okay.
It may potentially be helpful to graph it on your calculator while you're getting used to this.
That's what I think happens. I've never been good at mins and maxes and limits. They just don't make sense to me.
It comes with time.
I'm not so great with limits when I'm doing derivatives. If I'm just looking for like the limit of something.
All right. Find all possible functions f with the given derivative. So we're finding the antiderivative.
Joy.
So they tell us that f prime of x is equal to 2. And I want to work backwards. Okay? So basically, the derivative of what gives you 2?
X squared.
Oh.
No, not x squared.
Was I right?
What'd you say?
2x.
Yes.
Yeah.
Now, it says all possible. Okay? So f of x equals 2x, but it wants all possible. What happens when I take the derivative of a constant?
0.
It just, yes, goes to 0. It poofs away. So what I need to do is I need to add a plus c, okay? Which tells me, yes, I'm adding any constant value. It may simply be a 0. There may not have been any constant there. But if there was, I'm now accounting for it. So that's what that means. So you got to have the plus c part. That's probably the biggest thing people forget.
I like that problem.
32.
Maybe this is my thing.
F prime of x equals the sine of x.
I take it back.
The derivative of what is sine of x?
Negative cosine of x.
Yep, because the derivative of cosine is minus sine, but this is positive, so it has to be minus cosine. So f of x is minus cosine of x.
Let's see.
Yep, plus c. Even with the trig ones, we got to account for that, because we just never know.
I don't know if there was a c.
A little more crazy.
I am crazy.
F prime of x equals 1 over x minus 1, given that x is greater than 1. So the derivative of what gives me that? I actually think we did this one yesterday. Not like the derivative of this said thing, I think we did. What functions give us a derivative that ends up being a fraction? It's not asking you to undo the quotient rule.
Negative exponents.
Like the
Huh?
element or
Negative exponents.
Well, no, there's a specific derivative that we do.
Like that ln or the log one, or I can't remember. The ln.
Yep, ln of what?
X minus 1.
Oh yeah, because it's
Yep.
1 over.
Because the ln of x is 1 over x, so ln of x minus 1 would be just 1 over x minus 1. So this is the ln of x minus 1 plus c. I was trying to make y'all say it so you get used to it. So now you are starting to be able to work backwards.
Yay, we can press undo on our math.
Pretty much. All right, problems.
She just loves giving us problems.
1, 3. I mean, I'm a math teacher. I have a lot of them. 11,
Yeah, math teachers give us a lot of
15,
Yeah.
The bulk of my problems are for math.
19, And then 29, 31, and 33. So 15 and 19 are the ones where you need to take the first derivative, take the second derivative, find your critical points, find your mins and maxes, and then find your increasing and decreasing intervals.